For centuries, the Pyramids of Giza have stood in silence. Their peaks catch the first light of the rising sun. They have outlasted empires, watched the Nile shift its course, and guarded their secrets beneath layers of sand and time. Every stone and every shadow feels deliberate, as if the builders knew their message would need to last longer than memory itself. Most people see them as the height of ancient Egypt's mastery, a triumph of architecture, mathematics, and human determination. But others sense something deeper, hidden in their design. They hypothesize that the pyramids are not only monuments to kings, but messages from an age far older than Egypt. Some even suggest that the Great Pyramid might be the last surviving monument of a civilization that endured the world's greatest cataclysm, the Younger Dryas. Around 12,800 years ago, the Earth changed almost overnight. Ice melted, oceans rose, and fires swept across continents. Entire species vanished. If cities had existed then, they would have been erased and buried beneath flood and ash. Scientists still find traces of that disaster hidden deep within the earth, a thin scar of soot and molten glass, a silent memory of the day the world almost ended. The Great Pyramid itself is believed by some to hold that memory. Its base is level within millimeters. Its sides align almost perfectly with true north. Its proportions are said to mirror the curvature of the earth. No pharaoh's body was ever found inside. Above, the three pyramids are posited to trace the stars of Orion's belt, not as they looked in 2500 BC, but as they appeared more than 12,000 years ago. At the moment, Earth emerged from the Younger Dryas. Beside them, the Sphinx watches the horizon. Its body is marked by deep grooves of water erosion that no desert wind could create. Geologists theorize it once stood in a green and rainy Sahara, when rivers flowed where there is now only sand. Its gaze has not shifted for thousands of years. Through wind, rain, and time, it keeps watching, as if waiting for something to return. Satellite imaging appears to reveal the faint outline of an ancient river called the Ahramat, winding near the plateau. If the evidence holds true, Giza was once part of a living landscape, not the endless desert we imagine today, and perhaps the desert is not what it seems. Across the world, the same fingerprints appear: Göbekli Tepe in Turkey, Baalbek in Lebanon, Sacsayhuaman in Peru. Sites separated by oceans, yet sharing the same impossible precision and the same reverence for the stars. Myths from every culture tell of fire, flood, and renewal, not as prophecy but as memory. If that memory is real, then the Pyramids of Giza may not mark the dawn of civilization, but its return, a testimony of survival carved in stone by those who refuse to let their story die. Tonight, we explore that possibility. We will follow the evidence, from the scars on the Sphinx to the stars above Giza, and uncover clues suggesting that humanity's story may be far older than we have been taught. If you are still here, stay with us. Do you believe these monuments are proof of a civilization that survived the Younger Dryas? If you do, comment yes below. If not, comment no and tell us why. Please note, this story is based on established archaeological research combined with speculative hypotheses, aiming to offer a broader and more multidimensional perspective. We do not claim any of these interpretations as absolute truth, and mainstream history does not currently support the timeline presented in this video. To understand whether the pyramids truly preserve the memory of a civilization that survived the Great Cataclysm, we must go back to where it all began, to the moment when the Earth itself changed. About 12,900 years ago, Earth changed with a violence few species could endure. Temperatures plunged across the northern hemisphere, glaciers advanced, and storms reshaped the land. Forests caught fire, rivers overflowed their banks, rising seas swallowed coastlines that had existed for ages. Within a single human lifetime, the world that so many creatures had known simply vanished. This event is now known as the Younger Dryas. What caused it is still debated. Some scientists believe a sudden change in ocean currents froze the planet. Others hypothesize that a fragmented comet or asteroid struck Earth and unleashed global fires. Either way, the planet entered a period of chaos that reset everything alive. The proof of that catastrophe still lies in the ground. Across continents, from North America to the Middle East, Geologists have found a thin, dark layer they call the black mat. It contains nanodiamonds formed by intense heat and pressure. It holds tiny glassy spheres that melted from the surface and traces of platinum, rarely found in nature. Together, they form a silent record of an explosion so powerful it scarred the planet. It did not just end an age of animals. Some propose that it may even have erased the earliest beginnings of human memory itself. Yet even in destruction, life persisted. While the north froze, Africa turned green. When the ice receded, rains returned to the Sahara. For thousands of years after the Younger Dryas, the desert transformed into a patchwork of rivers, lakes, and fertile plains. This was the African humid period, lasting from about 14,800 to 5,500 years ago. The landscape was alive. Herds of elephants and giraffes moved through tall grass. Fish swam in deep freshwater lakes. Human communities thrived where today there is only sand. From above, satellites still trace the ghosts of those vanished rivers. One, called the Aramat, is believed to have once flowed past the Giza plateau. In that green world before the rise of Egypt, Giza may have stood beside a living river. A river is never just water. It carries food, stories, and memory. It gives a people the ability to move, to trade, and to remember. If any group had survived the chaos of the Younger Dryas, this would have been a place to rebuild. Giza offered safety, elevation, and access to the Nile. It was a place to carve memory into stone. Beside the Great Pyramid stands the Sphinx, older than any recorded king. No inscription names its builder. No ancient text describes its creation, but the rock tells its own story. Deep fissures and rounded grooves mark its body, not the work of wind but of water. They are the patterns left by long, heavy rainfall. In the early 1992, geologist Robert Schoch studied those patterns and proposed that the Sphinx had been carved between 9,000 and 12,000 years ago, when the Sahara was still green. If that timeline is correct, some theorize the Sphinx was built not in the age of pharaohs but in the aftermath of the Younger Dryas. That changes how we see it. The Sphinx might not have been a monument to power, but to survival. It could represent a civilization that endured the flood and remembered the stars. A people who carved order back into a world that had once collapsed. This might also explain why Giza became a site of impossible precision. The pyramids are aligned almost perfectly to true north. Their proportions reflect the curvature of Earth and mirror the belt of Orion. Such accuracy suggests intent beyond mere construction. It suggests continuity, the survival of knowledge through chaos. Most histories of Egypt begin with the unification of the kingdom around 3,100 years before the Common Era, but the stone and soil tell a longer story. It is not about beginnings but endurance. Some propose that the Nile Valley may mark the memory of civilization, not its birth, a refuge where survivors of an older world encoded their knowledge into geometry and light. And when the wind moves across the plateau today, it still passes over that question, quiet and unanswered. Who stood here to watch rain fall on the Sphinx? The Great Pyramid introduces a challenge that goes beyond the geological evidence of the Sphinx. It shows a level of technical sophistication that exceeds the known capabilities of the era to which it is assigned. The monument's geometry, construction tolerances, and absence of expected cultural elements raise legitimate questions about its origin, function, and chronological context. When examined alongside the Younger Dryas hypothesis, the structure begins to resemble not merely an Egyptian artifact but a potential legacy, possibly preserved by a civilization that endured the cataclysm and recorded its memory in stone. The foundation of the Great Pyramid spans approximately 13 acres and remains level to within only a few centimeters. The uniformity of this base, achieved without mortar across such a vast surface, suggests the use of advanced surveying techniques. The monument is also oriented to true north with an error margin of less than 3 arc minutes. This level of precision implies sustained celestial observation and an understanding of Earth's axial properties. These features do not appear decorative or symbolic. They reflect a systematic application of geometry and astronomy. Its proportions deepen the mystery. The ratio of the pyramid's height to the perimeter of its base approximates 2 times pi, a mathematical constant fundamental to the relationship between linear and circular dimensions. Expressing such a concept through architecture implies awareness not only of arithmetic, but of mathematical abstraction. Some scholars argue that this correlation may be coincidental, yet the consistency of these ratios across the entire structure suggests deliberate intent. The materials used reinforce this impression of technical mastery. The pyramid's outer casing was once composed of fine white limestone. The internal chambers, however, are built from granite blocks quarried in Aswan, more than 800 kilometers to the south. These blocks weigh between 50 and 80 tons each. Transporting and positioning them with millimeter-scale precision remains unexplained by conventional Egyptological models. Inside, the granite walls of the so-called King's Chamber display long, uniform striations. These markings have led engineers such as Christopher Dunn to propose the use of high-pressure mechanical cutting tools. While this idea remains outside mainstream acceptance, the smoothness and regularity of the surfaces are undeniable and have not been replicated using tools known from the Bronze Age. Another striking feature lies in the precision of the joints between adjacent blocks. Many of these joints are so finely fitted that even a razor blade cannot penetrate the seams. This level of accuracy suggests methods capable of mass-producing stone components to extremely tight tolerances. It is difficult to reconcile such workmanship with the hand tools typically attributed to workers using copper chisels and dolerite pounders. Despite its extraordinary engineering, the pyramid lacks the cultural markers expected of royal tombs from the Old Kingdom. No inscriptions cover its interior walls. No funerary goods or offerings have been found. No human remains have been conclusively linked to the structure. This absence stands in sharp contrast to the elaborate burial traditions documented in smaller tombs of the same era. If the Great Pyramid was intended as a tomb, it is widely noted that it fails to meet every known archaeological standard of one. This discrepancy has prompted alternative interpretations. Some suggest the pyramid served not as a mausoleum but as a functional structure, possibly related to energy, resonance, or the preservation of information. Christopher Dunn has argued that the combination of granite, limestone, and the pyramid's geometry may indicate acoustic or electromagnetic properties. Though speculative, such ideas arise from the challenge of explaining the observed precision within the limits of Bronze Age technology. Further evidence adds to the mystery. The pyramid contains 4 narrow shafts extending from the king's and queen's chambers. These are often described as ventilation shafts, yet they do not allow airflow and terminate near the outer surface. Their alignment, however, corresponds with specific celestial bodies. The southern shaft of the king's chamber points toward the constellation Orion, while the northern shaft aligns with Thuban, the pole star around 2,600 years before Common Era. Some researchers note that the most accurate alignment occurs not in that dynastic period, but closer to 10,500 years before Common Era. That date aligns with the end of the Younger Dryas. This correlation may reveal an attempt to encode a moment in astronomical history. If the alignment was intentional, it suggests that the structure was designed to reference a specific epoch, possibly not the time it was built, but a much earlier event. This idea supports the theory of the pyramid as a memory device, a fixed point of reference through which a future civilization might rediscover lost knowledge. In that context, the absence of inscriptions becomes meaningful. Written language fades with time and translation. Geometry and starlight do not. The Great Pyramid is hypothesized not to represent the peak of Egyptian achievement, but a remnant of something older, designed, preserved, and later repurposed. In that light, its deviations from known patterns are not flaws, but signatures. They distinguish it not only from the monuments that followed, but from the civilization to which it is usually assigned. This does not prove that a pre-cataclysmic civilization built the Great Pyramid, but it does show that its origin and purpose remain unresolved within traditional chronology. And it leaves us with a question that has echoed for millennia. If a civilization survived the Younger Dryas and sought to encode its knowledge in a form that could outlast climate, language, and empire, what would that monument look like? Perhaps like this one. Giza is not alone. Across the world, other ancient monuments show remarkable precision and a shared fascination with the stars. To trace their origins, we look beyond Egypt and further back in time, to the period that followed one of Earth's greatest climatic events. In southeastern Turkey, one site stands as a symbol of that new beginning, Göbekli Tepe, dated to around 9,500 years before Common Era. It rose at the edge of the Younger Dryas recovery. What makes this place remarkable is not just its age, but its sophistication. The site predates pottery, metalwork, and agriculture, yet it displays architectural planning and symbolic design far beyond what is expected of hunter-gatherer societies. Massive T-shaped limestone pillars, some weighing more than 20 tons, were arranged in circular enclosures. Each stone was carefully carved and positioned. The pillars are decorated with foxes, boars, cranes, and serpents, along with abstract shapes that may have held ritual meaning. No homes or settlements have been found nearby. Göbekli Tepe was not a village. It is considered to have been something different, a structure built for ceremony, for observation, or perhaps to remember something that came before. Archaeologists discovered that Göbekli Tepe was later buried under tons of soil and stone. The filling material came from the same era, showing that the people who built it were the same who covered it. The reason remains unknown. Whether it was to preserve, protect, or conceal, no one can say, but that act ensured its survival. For thousands of years, it lay hidden beneath the earth until excavations in the 1,990 seconds revealed its carved pillars once again. The precision of the site raises questions about how early humans organized and worked together on such a scale. Limestone was quarried locally, shaped with flint tools, and transported with care. The coordination required implies leadership, planning, and knowledge passed through generations. Göbekli Tepe stands as the first known example of monumental architecture, long before the rise of cities or temples. Far beyond Anatolia, other ancient monuments share the same traits of precision, scale, and mystery. In Lebanon, the site of Baalbek holds 3 massive foundation stones known as the Trilithon. Each weighs over 800 tons. They form part of an ancient terrace that was later reused by Roman builders. The placement of the stones is exact. Their faces are smooth, and the joints between them are almost seamless. Nearby, in the same quarry, lies an even larger block known as the Stone of the Pregnant Woman. It weighs more than 1,000 tons and remains unfinished. Moving and aligning such stones required planning and skill beyond anything easily explained by the tools of the time. Across the ocean, in the highlands of Peru, stand the walls of Sacsayhuaman. Built from enormous limestone blocks, some weighing more than 300 tons, the walls curve and interlock like puzzle pieces. Each block has a unique shape, yet they fit together so tightly that no mortar was needed. The surfaces show signs of smoothing and heat exposure, suggesting careful refinement. A short distance away, near Lake Titicaca, the ruins of Pumapunku reveal andesite blocks with perfect right angles, straight grooves and interlocking shapes. The precision of these cuts suggests a mastery of geometry and engineering that remains difficult to reproduce even today. Across continents, these monuments share a fascination with alignment and the sky. Many are oriented towards solstices, equinoxes, or the rising of specific stars. In Egypt, the Great Pyramid of Giza aligns almost perfectly with true north. At Göbekli Tepe, several enclosures face the southern sky, where the star Sirius would have appeared around 9,500 years before Common Era. These alignments reveal that ancient builders were observing the heavens and marking time with astonishing accuracy. The world's oldest stories seem to echo these same patterns. Myths from many cultures describe a great flood, destruction, and renewal. In Egypt, Zep Tepi recalls the first time, when divine order was restored after chaos. In Mesopotamia, the Epic of Gilgamesh tells of Utnapishtim, who survives a flood and carries the knowledge of the old world. In India, Manu is warned by a divine guide and saves life from the waters. In Greece, Deucalion and Pyrrha survive the flood of Zeus and begin again. Though separated by geography and time, the stories share the same theme: a world destroyed and a few who remembered. Modern research adds another layer to these connections. Genetic and archaeological evidence shows that after the Younger Dryas ended, populations migrated from Anatolia and the Caucasus toward the Levant and the Nile Valley. These movements occurred around 9,000 years before Common Era, roughly the same period when early agriculture began and permanent settlements appeared. The knowledge of building, farming, and measurement may have travelled with these people, carrying fragments of a memory older than recorded history. From Turkey to Lebanon, from Peru to the Nile, the evidence is interpreted by some to suggest a long chain of knowledge stretching across time. The builders of these monuments may never have known each other, yet their work carries the same signatures: scale, accuracy, and a shared relationship with the sky. The pattern hints at continuity, as if a fragment of ancient understanding had endured through catastrophe and was reborn in new forms. When the sands of Giza settle at sunset, the stones still glow with reflected light. They stand silent but complete, carved from memory and purpose. If the Pyramids of Giza prove anything, it is that knowledge can survive even the fall of worlds. The people who built them may have lived thousands of years apart from those at Göbekli Tepe, but they carried the same impulse to endure, to measure, and to leave behind something that time could not erase. Perhaps that is the true legacy of the Younger Dryas, not only destruction, but the will to remember. And in the heart of Egypt, that memory still stands, written in stone beneath the eternal sky. As the thread of ancient memory winds across the world, it returns once more to the desert of Egypt. Beneath the endless sands, Giza stands as both monument and mystery. For centuries its stones have been studied, measured and mapped, yet the story they tell may not be complete. Modern eyes now look beneath the surface, and what they find suggests that the monuments of Giza may be more than what we see. They may be only the visible edge of something larger, older, and far more deliberate. In 2017, a quiet discovery inside the Great Pyramid captured the attention of the world. The Scan Pyramids project, a collaboration between Egypt, France, and Japan, used a form of cosmic imaging called myography to search within the pyramid's dense stone. High above the Grand Gallery, the sensors revealed a long, empty space more than 30 meters in length, sealed away for thousands of years. No passage leads to it, and no ancient record describes it. The space has never been entered. Some call it a void, others believe it may have served a purpose now forgotten. For centuries, people imagined the Great Pyramid as mostly solid, but the discovery of that hidden space suggests a structure more complex than expected. If one chamber remained unseen for millennia, others may too. The pyramid seems built not only to endure but to conceal, guarding its design, its secrets, and perhaps its memory. Beneath the ground, the story deepens. The three great pyramids rise above the plateau, but their foundations rest upon layers still unexplored. Under the sands, the land hides traces of structures and pathways now buried by time. Egypt's Ministry of Antiquities estimates that less than 2% of the country's ancient sites have been excavated. The rest lie unseen, hidden beneath modern cities, beneath dunes, or beneath the floodplains of a river that has long since changed its course. From above, the technology of the present is beginning to trace what the past left behind. Satellites and ground scanning instruments reveal faint outlines below the surface, straight lines, corners, and repeating angles. Some form grids that spread outward from the pyramids. Others mark foundations or corridors invisible from the ground. These patterns do not belong to the desert. They belong to design. They hint at a landscape once planned, once active, and later lost beneath the slow work of sand and wind. A buried river also runs near the edge of the plateau, its path found through radar and satellite imaging. Scientists call it the Ahramat River. Long ago, during the African humid period, this river flowed wide and steady through what is now desert. If it ran beside the pyramids, then Giza once stood in a land of water and green, a place of movement, ceremony, and life. The builders could have chosen this spot for that reason. The river might have carried the stones. It might have served as a sacred path or a mirror for the stars. Whatever its purpose, it means that Giza was once part of a living world, not the barren plateau we see today. Only a small part of that world has been uncovered. Much more remains beneath. The instruments that now scan the desert continue to find hidden shapes, the geometry of roads, walls, and chambers carved deep below. Each signal marks another fragment of history waiting for air and light. Together, they suggest that Egypt's story may not begin where we thought. Instead of a sudden rise around 3,000 years, Before Common Era, it may reach back further, connected by layers of memory that time has not erased. When light falls across the Great Pyramid, its stones catch the same shadows they have held for ages. Beneath them, spaces remain silent and untouched, their purpose still sealed. To some they are tombs, to others temples. But perhaps they were neither. Perhaps they were messages meant to last until the world was ready to hear them. Perhaps the builders never meant for us to understand at once. Perhaps they left what they could in the only language that could outlast wind, flood, and fire. The language of geometry, carved into the bones of the earth. The rest, they left to time. So now, when the question is asked, not what the pyramids were built for, but what they are still hiding, the answer may not come from myth or from faith, but from the stone itself. Beneath the sand, the silence waits. And if the stones hold a message, it is hypothesized that it is not about them, it is about us. In 2025, new satellite imaging was reported to reveal patterns beneath the sands of Egypt that had never been seen before. Using high-frequency radar and sub-millimeter spectral scanning, scientists from the European Space Agency's Terraformer program detected buried structures beneath the Giza Plateau. They found corridors and foundations stretching far beyond the known pyramid complex. The data appeared to show angular disturbances in soil density and magnetic fields, as if something vast still lay hidden below. In May 2025, researchers at the Institute for Anthropogenic Pattern Analysis used artificial intelligence to compare megalithic structures around the world. They discovered a repeating geometric ratio linking the Great Pyramid with ancient temples in Java and pre-Inca platforms near Lake Titicaca. The same proportions, the same symmetry, and the same stellar alignments appeared across continents separated by oceans and millennia. Whether by memory or coincidence, the pattern was unmistakable. These monuments were built to last. The discoveries of 2025 revived an old question. What were the pyramids really for? Some now believe they were more than royal tombs, that they might have been designed to protect civilization itself. If the world once faced catastrophic floods, the pyramids could have served as refuges, built high above the floodplain and sealed to withstand disaster. Today, scientists warn that the Earth is changing faster than ever. Global temperatures are higher than the year before. Ice that has stood for thousands of years is melting and sliding into the sea. Sea levels are rising, storms are intensifying, and the seasons are beginning to shift. Around the world, coastlines are shrinking, forests are burning, and entire ecosystems are struggling to survive. Ancient humans once faced great changes when the last ice age ended and floods reshaped the land. Now, it is our turn to prepare and take action to protect the only home we have. If you found this story meaningful, please like, share, and subscribe to support our work. Leave a comment and share your thoughts with us. See you soon, and good night.